Bismillahirrahmanirrahim. Uh, Today I am going to talk about gradient descent, and I want to implement gradient descent in Java language. First of all, I will introduce what is gradient descent. Gradient descent is an iterative optimization algorithm for finding the minimum of a function. It is commonly used in machine learning to train data model. The idea is to start at a point and then move in the direction of the steepest descent until you reach a minimum. The gradient descent algorithm calculates the gradient of a function at the current point and then move in the opposite direction. The step size is determined by the learning rate. The gradient descent algorithm is repeated until the error is minimized. What is the error? The error is the difference between the actual value and the predicted values. So this is the mathematical form of gradient descent. This is the function, and this is the actual size from where we start. Then uh, uh, from the start point minus learning rate. Learning grid is the step from which they move to the other steps, and the other is the derivatives of the x, which is a function. So this was just a short introduction of gradient descent. I hope you will understand. Let's go to the implementation part. I am going to implement the gradient descent in the Java language. From the introduction part, we learned that we have three main faults to have in our mind. That first point is the learning rate. The second one is the starting point, or the third one is a function which we are going to find the minimum um, uh, point of this function. So first of all, I will introduce a function. I will not public static double double x. I want to give a name to the function. I want to name this function for exponential. Just I name this function as the name of exponential, and I want to return. I want to have a function something like this: x times x return. This is the function. The second one, I want to uh, calculates, or I want to have a function for to calculate the uh, derivatives of this function for us. Public static double, and the name of the function is derivative, and they have uh, a variable which they accept a variable of double, and derivatives of this function is something like this: return 2 times x, 2 times x. These are our function which we initialized. Now we are going to come to the main function. In the main function, we have three things to be initialized. The first one is uh, double learning rate. Learning rate is something which they have a step to go to the steepest point. This is something 0.1, and the second one is int iteration. As we mentioned that gradient descent is an iterative procedure, and we want to have just 10 iteration. And the third one is double x. X is the point from this which we are going to uh, start to find the minimum point. And this is 10.0. Just I want to uh, have a loop for iteration for int I is equal to 0. I is um, mm, less than iteration I plus plus. Mm, just we are going to have for each iteration we are going to have uh, mm, a derivative of this function. And for this we are going to have a variable double gradient mm, uh, derivative of x, and we are going to have also have now we are going to find the gradient descent. Gradient descent is x equal x learning rates times gradient learning rates time gradient. Now I think this is learning rate time period, and I want to have also a cost function. Cost. For this function we are just exponential just have an x. Now I am going to print the cost function and also the gradient descent of this function system dot out dot print ln. And in this function I first of all I will have iteration. I want to plus I plus 1 uh, just plus, and this x I want to print the x values. The gradient descent of this function x, and this is something x plus x, and after that I am going to uh, print cost function also. Cost. For this I will have a cost function. So, and this is our function. uh, First I will run what will I have for the result. This is our result, and I am going to apply on this something thread to have uh, uh, sleep among each print. So for this, I'm going to use a thread.sleep function. Thread.sleep function needs try and catch exception e and e dot prints to print the error. So this is the sleep function, and two, after 2 seconds each print should be done. So I'm going to run this function to see what will I have as a result. This is our first iteration, and this is our second iteration, third, fourth, sixth, seventh. As we saw that for each iteration, its gradient descent is minimized. So for the first one, it is something 8.0, and it is reducing until it is reached up to 1.07 to 0.73, and our aim, which was to minimize the difference between the actual value and the predicted value, we have reached. So thanks for watching this video.